Hey guys, it's Mr. Lowry. If you weren't here today, this is either 1026 for A Day or 1027 for B Day. I wanted to give you some help getting started on this assignment. It's called Game Day, Standard Form Practice. So we're going to be practicing using standard form, which is another form of linear equations. Standard form looks like this. AX plus BY equals C. So you have an A and you have an X and a Y. And then in front of that, you have a number in front of X and a number in front of Y, and then another number on this side. So this looks a little bit different than the other forms that we've used. And just to review some of the other forms, we had point-slope form, which is y minus y1 equals m times x minus x1. That's really handy if you don't have a y-intercept, but you do have a point and a slope. You can use this one. And then, of course, our favorite one, the one we're most familiar with, is slope-intercept form, right? Y equals mx plus b. And in both of these, m equals the slope. This one uses a point, x1, y1, and then this one uses a y-intercept. So this one looks a little bit different, but it's really handy for a lot of times real-world scenarios, which we're going to see in this assignment. So in this assignment, we're talking about getting ready for a football game. So it says, your school's football team made regional finals, and as the team manager, you're helping to plan a trip to the big game while doing some fundraising and selling team merchandise. Work through each scenario to get the rest of the story. So you're the team manager, you're going to help plan this football game and make some money here along the way. The first scenario says, the team, the school band, and the support staff are going to need transportation across town for the game. Your school has some buses and some vans you can use. Buses hold 24 people with all their equipment, and vans can hold 8. And we need to transport 120 people total. So what we know is buses can hold 24 people, vans can hold 8, and we want to transport 120 people total. What we don't know is how many buses we're going to use and how many vans we're going to use. That kind of depends on our choice. But what we can do is make a variable for each. So we'll say x equals the number of buses, and y equals the number of vans. Since we don't know what they are, we're just going to represent each one with a variable. So in part A, it says write an equation in standard form that represents all the combinations of buses and vans you can use to transport everyone to the game. So I got 24 people in each bus, but I don't know how many buses I'm going to use. And I'm going to add that to 8 people in each van, but I don't know how many vans I'm going to use. What I do know is that number should total 120 people. That's how many people I have to transport. So this equation is in standard form, right? It's a number times x plus a number times y equals a number. So this is kind of a nice format for representing this scenario here. All right, if I use only vans, how many vans will I need? So only vans tells us 0 buses. Okay, and if I'm going to use 0 buses, then I can just use my standard form equation to figure out how many vans I'm going to need. So I have 24 people per bus, but I'm going to have 0 buses. And then 8 people per van, and that should be 120 people. We don't really need this part of the equation right now because 24 times 0 is 0, but we do know that x is going to be 0, right? So 0 buses. Okay, now the rest of this we just need to solve for y. So if I divide both of these by 8, I'm going to get y equals 15. Okay, so the answer to this question we want to say is 15 vans, 0 buses. But remember that this is a coordinate because we plugged in 0 for x, right? So we have 0 buses and 15 vans. That's what this point represents. Okay, part C. If we use only buses, how many buses will we need? All right, so again, only buses tells us something about the vans. It tells us there's 0 vans. So 24 people per bus times the number of buses, which I don't know, plus 8 people per van, but we know there's 0 vans this time. Okay, is going to equal 120. Now again, 8 times 0 is just 0, so we don't have to worry about that piece. But we do have to worry about the 24x. So 24x equals 120. We're just going to divide both sides by 24, and we're going to get x equals 5. So that's 5 buses. Okay, now remember, just like in last time, we can represent this with a point, which we'll use later. This was when the number of vans was 0, so y was 0, we had 5 buses. Okay, so notice we have these two coordinates that we're going to use later when we graph. And this one, if you want to make a note to yourself, this is actually going to be the y-intercept, because if x is 0, this is going to be on the y-axis. And this is actually going to be the x-intercept. That'll be a little easier to see on our graph. Okay, so now we want to make a graph to find all the different combinations of buses and vans we could use. Now these are just two combinations, right? I could have 0 buses, 15 vans, or I could have 5 buses, 0 vans, but I can also have some combinations in between. So we're going to make a graph. Now it says think about whether we need negative numbers. We're not going to have to worry about negative buses or negative vans. That doesn't really make sense. Each point here is going to represent a combination of number of buses and numbers of vans, just like we have here. So that's what the points are going to represent. We'll talk about connecting the dots as we go on the graph, and then we want to make sure we scale our graph so we can fit everything. And then we're going to list all of our combinations here. So let's jump to graph paper so we can take a look and see what this is going to look like. Now I'm going to start out with my x and y axis, and since we already labeled the x and y variables, this should be pretty easy. Okay, remember that the x-axis was the number of buses. So I'm going to label that number of buses. And then the y variable was the number of vans. Okay. And remember that the very first combination that we found was when we had 0 buses, we had 15 vans. So if we have 0 buses, this is 0 buses right here. We'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Sure I did that right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, cool. So this point represents 0 buses, 15 vans. Okay? And you'll notice that this is the y-intercept because it's on the point that's on the y-axis. So this is x and this is y. Okay, the other point that we had was from that other piece of information, I think it was part C, where we had to figure out, well, what if we had 0 vans? And if we had 0 vans, we had 1, 2, 3, 4, 5 buses. So this is the point 5, 0. Right? 5 for x, that's the number of buses, 0 for y, that's the number of vans. All right, so we have these 2 points. Now what we want to do is find out all the other combinations. So I could come here and draw a line between these 2. Whoops. There we go. And this line should give me other solutions or other combinations of buses and vans. The problem here, though, is if this is like 0 buses, 1 bus, 2 bus, 3 buses, 4 buses, 5 buses, right? In between here, like if I picked a point that was in between, that would be like half of a number of buses, which we can't really do. We got to kind of use, if we're using a bus, we have to use the whole bus. All right, and also similar here, if we go halfway in between, then we're going to have half of a van, and we don't want to do that. So what we're looking for is we're looking for points that actually go through a nice, even grid intersection. We don't want any of these halves in between. So this one looks really nice because it goes right, it's right in the middle of a grid intersection. And this one as well, and this one as well. Okay, so it looks like these are our points, and we could label them. So this guy would be 1 bus and 12 vans, right? So this is the point 112. This is the point 2, 9. So that's 2 buses and 9 vans. This is the point 3, 6. So that's 3 buses and 6 vans. This is the point 4, 1. Excuse me, 4, 3, sorry. 4, 3. So this is going to be 4 buses and 3 vans. And these are all our different combinations, right? So we don't really want the in-betweens. If we wanted to come back, we could actually erase this line because in this context, we can't really use half of a bus or half of a van, so these in-betweens don't really make a whole lot of sense. But these are our different combinations. Okay, one of the other things I wanted to mention to you or to show to you is that you can kind of find the slope of this line. So every time we go down 3 vans, we can go up 1 bus, right? So down 3 vans, over 1 bus, down 3 vans, over 1 bus. You can see this pattern. So the slope is kind of helpful here because every time I go down 3 vans, I can go up 1 bus. In other words, that's kind of like an exchange right here. I can exchange 3 vans for every 1 bus because a bus holds 3 times the amount of people that a van will. So using the slope here is kind of helpful to be able to find your other coordinates. So going back to the problem that says list our combinations below. So we made a graph, and that will be part of what you're going to turn in. But we have 0, 15, right? And we have 1, 12, and we have 2, 9, and we have 3, 6, and we have 4, 3, and we have 5, 0. So remember, every time we go down, or if we want to go up 1 bus, we have to go down 3 vans. Every time I go up 1 bus, I'm going to go down 3 vans, and that's the pattern that you see here. So these are the different combinations that we can use, and they look like on the graph they're coordinate points. All right, let's take a look at number 2 here, and then I think you should be good to go on this assignment. So similar idea, right? But this time we are talking about shirts. So we've just figured out how to get everybody to the game. Now we're going to figure out how to make some money at the game. So we're going to order some t-shirts and we're going to sell them at the game. Okay? Short sleeve shirts cost $10 each. Now we're going to order these shirts. And long sleeves cost $12 each. But this is how much we want to spend on the shirts altogether. Okay, so we know how much each short sleeve shirt costs, we just don't know how many of them to order. So X equals number of, I'm going to go SS for short sleeve, okay, and then Y equals number of LS, I'll go for long sleeve. Okay, I don't know how many of those. I do know how much they cost, I just don't know how many I'm going to order. And I have to make sure that I don't spend more than my budget. So if I'm going to write this in, it says write an equation, we're going to use standard form. Okay, so $10 a shirt times the number of short sleeve shirts will be the number of the amount of money I'm spending on short sleeve shirts alone. I have to add that to the amount of money I'm spending on long sleeve shirts, which will be $12 for each of those. I just don't know how many. I do know, though, that should equal $300 because I don't want to spend any more than $300. That's my budget. So this is my standard form equation. Okay, if I only order short sleeve shirts, how many can I get? So I'm only going to order short sleeve. That means 0 long sleeve shirts, or Y is going to be 0. So 10X plus 12Y, but remember Y is 0, 0 long sleeve. That should equal 300. Now this piece we can get rid of. So 10X equals 300, or $10 a shirt times the number of shirts is going to be $300. If I divide both of these by 10, I get X equals 30. Or in other words, I can get 30 short sleeve shirts if I get 0 long sleeve. Okay, so we want to go 30 short sleeve. Okay, but remember we can represent this as a coordinate, which we're going to probably do later. Okay, if I only order long sleeve shirts, how many can I get? So again, this is going to be 0 short sleeves if I'm only ordering long sleeve shirts. That's 0 short sleeves. So 10 times 0, $10 per short sleeve shirt, I'm going to get 0 of them. I'm going to add that to 12 times the number of long sleeve shirts I get, and that better be 300. Okay, so I get 12Y equals 300. And then when I do 300 divided by 12, I should get the amount of long sleeve shirts I can get. So 300 divided by 12, just doing that on my calculator here. Okay, so that's Y is equal to 25. So 25, that's long sleeve shirts. Assuming I don't get any short sleeve. Okay, so now I want to make a table to find all the combinations of short sleeve shirts and long sleeve shirts I can order. Okay, now I'm going to make this table in my graph paper. I think that will be helpful. So let's jump over to that, and let's keep in mind that I have these 30 short sleeve shirts, 0 long sleeve, 25 long sleeve if I have 0 short sleeve. So we'll start there. Okay, so this is the next problem here. I'm going to make a line to differentiate between my next problem. And I'm going to make a table. Okay, and on the left hand, I'm going to put my x variable, which was short sleeve. And on my right, I'm going to put my y variable, which was long sleeve. And then I'm going to put a couple points on here. So the two combinations I already know is I could get 30 short sleeve shirts if I get 0 long sleeve. We already talked about that. We also know that if I get 0 short sleeve, I can get 25 long sleeve. So those are my two points that I have so far. If you were to graph these, which you're not going to, this would be the x-intercept, and this would be the y-intercept. Okay. Now what we need to do is we need to find out how to get in between these. How do I transfer from one to the other? And in order to do that, what I'm going to do is I'm actually going to find the slope between these two. So if you think about these as 2 points, 30, 0, and 0, 25, I can easily find the slope between these two guys. If this is x1, y1, and this is x2, y2, then the slope will be 25 minus 0, y2 minus y1, over x2 minus x1, which would be 0 minus 30. So 25 over negative 30, because 0 minus 30 is negative 30. That's going to simplify to negative 5 over 6. Okay, so this is my slope, but let's think about that in context of the problem. Okay, so this is the change in y, and this is the change in x. And remember, y was long sleeves. So negative 5 long sleeves, and then 6 short sleeve. Right? That's what I could read this as. This is down 5 long sleeves, up 6 short sleeves. Or in other words, I can trade 5 long sleeve shirts for 6 short sleeves. Every time I get 5 less long sleeves, I can get 6 more short sleeves. So if I go down 5 long sleeve shirts, I can get 6 more short sleeve shirts. If I do that again, if I go down 5 more long sleeve shirts, then I can buy 6 more short sleeves. So this is almost like an exchange rate. I can exchange 5 long sleeves for 6 short sleeves. Okay, now we can do it the other direction as well. So negative 5 over 6, I could also write as 5 over negative 6, which would be if I go up 5 long sleeves, I have to go down 6 short sleeves. Right? So if I go up 5 long sleeves, I have to go down 6 short sleeves. Okay, and I could do it again. If I go up 5 more long sleeves, I have to get 6 less short sleeve shirts. Okay, now these are kind of meet in the middle, because the next one would be 5 more long sleeves. I would be at 15. So I have a little extra space in here because I didn't know how many points I was going to need. But this is now my table with all my combinations. But slope is important here because it tells me my exchange rate, basically. If I decrease one amount, I have to increase the other one, and vice versa. So this is going to be my table here. If I just got to go back and kind of copy that right here. Okay, we have X and Y, or short sleeve and long sleeve. And I started out with 30 and 0, and then I had 24 and 5, and then I had 18 and 10, then I had 12 and 15. I had, let's see, that would be down 6. I have 6 and 20, and then I have 0 and 25. So remember, the slope is telling me, negative 5 over 6. Every time I go down 5 long sleeves, I can get 6 more. Or if I have 5 over negative 6, same kind of idea. Every time I'm going up 5, I'm going to go down 6. So this is like a plus 5, plus 5, plus 5, minus 6, minus 6, minus 6. Okay, now you don't have to write that in your table. The table is just this part, but you can see those patterns there. Okay, so So there's your table with all your different combinations that you can get. All right, now for the rest of this, you're just going to do some similar stuff. So you get to keep kind of going through the scenario. Once you buy all the shirts, you're going to turn around and sell those shirts for a profit. So number 3 is similar to number 2. You're going to find all the combinations of short sleeve shirts and long sleeve shirts that you need as well. This time you're selling them though. And you can either use a graph or a table on here. I didn't tell you what to do, but we've done both now. And then number 4 here, same kind of idea, but now you're buying nachos and hot dogs for a certain amount of money, and you want to figure out the different amounts of hot dogs and nachos that you can get. And this one asks you to make a graph. Okay, and then the last one is talking about the actual football game. There's 2 ways to score in a football game. One of them is getting a touchdown, and one of them is getting a field goal. And this asks you, what different combinations can you get to get up to 63 points total. Okay, so that's kind of what you're going to do on the rest of this. You got the first 2. Just apply that same information to the rest of it and finish this guy up. Thanks.